So let's discuss the problem, remove element of Leetcode. So given in the question, as we can see, we have a we have given a vector of int types. Okay, so we're given a vector of int types and a vector of int types called nums and a value of int type. So basically what the question says is you have to so we have to remove all the elements that are equal to val. So we have to remove this element and this first element and last element, and we need to shift. So yeah, and we need to shift them like to the end positions. So basically I'll tell you the crux of this. So basically what it is asking is that we remove them by shifting this element to the end. The value, whatever element is equal to value, we shift them to the end of the array, and then what do we do? And then we return how the occurrence of the value, and that will give us that will basically no no then what do we do? Sorry, I'm sorry. So then we return the elements which are not equal to value. So that in this case, let's see. Okay, so this is a array of how many elements? 5 8 elements. Okay, so value is 2. So how many 2's are there? 1, 2 and 3. There are 3 2's. Okay, there are 3 2's, and now we shift all of these 2's at the end here. Okay, and then what do? We return the amount of elements which are which are not equal to value. Okay, the amount of elements which are not equal to value, and those will be displayed. Okay, so that's basically the logic and the crux of it. Now let's go for it. Okay, so it's a pretty simple problem. So what you have to do is, so first thing, let's see, so we need to shift it to the end. So let's take int I equal to 0. I is a pointer which is equal to 0, and we'll take j also, which will point to the last element of the vector nums. It will point to the last element of vector nums. Okay, so now this is done. Okay, now let's, so there's a edge condition. Okay, there's a edge condition. If imagine if nums is just like the vector given to us is empty. What if nums is empty? So nums is empty, so nums dot size is equal is empty, basically is equal to 0. Nums dot size is 0. That what that means? It means that nothing is. So what you have to do is return 0, nothing. It is written nothing. Okay, so this is the edge case, we have covered it. Now let's go to the algorithm. So to better understand this, so now let's continue. So these two are very important now. Yeah, so basically, yeah, so basically now this is there. Now let's continue. So what we did, I equal to 0 and j is pointing to the last element. Okay, then we'll run a while loop. Okay, until I, the I pointer is less than the j pointer. This while loop will run until that condition holds true. Now the condition is hold true. Now what are we gonna do? If, okay, if nums of I is equal to the value that is given, that means we need to delete it, and delete it means basically shift it to the end. Okay, so what, to shift it to the end, who is pointing to the last element? Yes, that's right, j. So what we do, we swap, what we do is we swap nums of I with nums of j. Simple. So we have swapped these elements, so now it's at the end, and whatever element was at j is here. Now there's a, okay, so now then we swap this. Okay, and then we do I No, we don't do I plus, we do j minus minus. Now you're saying, and we don't increment I at all. Now you're like, what? Why don't we increment I at all? So let me explain to you. Okay, see now. This element, this array, we'll see. Okay, let me just explain on this array. So this array is there. Okay, so now I is pointing to element 0 and j is pointing to element 2, right? And val is also equal to 2. So what happens is if when we come, so it runs. Okay, so nums of I equal to val, this condition, nums of I equal to val, is it equal to val? Yes, it is. No, sorry, it's not. So nothing will really happen. So yeah, let's just make changes. So imagine this is 2. Okay, so now is nums of I equal to val, will this hold condition hold true? Yes, it will. So what it will do is, so the it will swap I and j. So the new value of I, so here it's 2 initial value, so the new value of I is also 2 and j is also 2. Okay, so you can see the, I hope you have like got the edge case and the problem here. So yeah, basically the problem is, what happens is, if you go if you do I plus plus, it will go to 1. Okay, but as you can see that this, the first element is still 2, and we want that 2 not in the start of the array, but all the 2's, all the elements which are equal to the value, we want them at the end of the array. So this is a major blunder, and this will obviously result in a wrong output. So what do we do? How do we fix this? Simple. Okay, it's very simple. So simply what do we do is, we use this condition. So we just do j minus minus, we don't do I plus plus. So what that does is, so we do j minus minus, so now j is pointing to 4. Okay, and I is still pointing to the first element. Now what happens is, so this is 2, this is 4 now, and now they swap. Now in the next iteration, I equal to, okay, now I equal to 4 and j equal to, okay, now let me write the else condition. Else, if it's not there, then do I plus plus. Yeah, so simple. Okay, so j equal to 4. Yeah, j equal to 4, and I equal to 2 still. Okay, now we swap them. So what happens is, this one becomes 4, this one becomes 2. So now this becomes 4, this becomes 2. Okay, and then when you swap them, as these are now swapped, as you can see, we've got 4 in the start and 2 is at the back, as it should be. And then you can proceed to the next element when they are not equal. So as you can see, 4 is not equal to the value, therefore we do I plus plus. Simple as that. So this is basic, very basic. It's a very short code and just nice logic. So yeah, this is enough for solving the, like swapping and putting it in the order we require. This is all to get into the, this code gets it to the order we require. Khalas. Now this is done. Now let's see. So we need to return. Okay, now our task is, we need a int return type. Okay, now we have put it in the correct order. Now we need to return the amount of elements. Okay, we need to return the amount of elements which are not equal to the value. Okay, so let's see what can we do. Now it's in the order we want. Okay, so all the 2's are at the end. Now let's see, I'm taking this example now. Okay, so 0 1 4 0 3 2, this is our element. Now after running the whole code, after running this code, we get this. Okay, so now what do we want to return? These many numbers. How many numbers? 1 2 3 4 and 5. So we need to return 5. Okay, so now how can we do that? Okay, so the solution to this is, it's simple. Okay, what we do, let's take a pointer k which points to the last element of nums. Okay, k is pointing to the last element, k is pointing here now. Now what do we do? Simple, we just run a while loop until nums of k is equal to the value that has been given. Now what do we do? Okay, and one more we'll take int answer. This is to store. No, yeah, okay, nothing. We don't need anything else actually. Yeah. So then we do k minus minus. So okay, now let's see how this works. Okay. Okay, so k is initially at 2. Okay. Now this runs. So while k equal to, okay, it 1. Okay. So k equal to how much? 7, right? Because it's pointing to the last. No, actually 1, 2, 3, 4, 5, 6, and 8, 8. It's equal to 8. But we're doing 8 man. Okay, 7, 7. As iterator wise, it's equal to 7. Yeah. And then, like, at the position, it's not giving this thing. It's not giving the exact. It's 0 base indexing. That's why it's 7. Okay, so now what we do is, in the first iteration, k minus minus happens. K value becomes 6. Okay, then and this is how k minus minus only happens when nums of k is equal to value. So nums of k is equal to value. Yes, in this last position case we can see that value is equal to 2 and nums of k is also equal to 2. So that happens. Now iteration 2 happens. You can see that, you can see in iteration 2 that k is equal to 6, and then again k minus minus takes place. Why? Because it's pointing to this currently now, and it's also equal to value, and then what, k becomes 5. Okay, now let's go iteration 3. Now k is equal to 5. Again k minus minus happens. Why does it happen? Because it's equal to value again. Yeah, so k minus minus happens. K is 4. K is 4. Now iteration 4. Okay, now iteration 4 we see that at the 0, 1, 2, 3, at the fourth index, you can see nums of I is not equal to value. So what happens? Simple, nothing. Just nothing happens. This condition just fails and it just exits out of the while loop. And now we are here. So now what do we have to do? Simply just return k value. But remember, k value was in 0 base indexing. So we need to return k plus 1. Because you can see that our k value currently is 4 and what we need is 5. Basically 5 positions. It's correct, only it's 0 base and just convert to 1 base. Okay, so that's it. Let's run and see. So it's accepted. Okay, so we have a problem. So nums of 1, 1. So okay, let's see. Size minus 1. So 0, 0 equal to value s k minus minus. Okay, yeah, one more. Oh, yeah. So basically, what the problem is happening is, it's okay. So what happens is here it's you guys check the condition, but I'll just write the code. So k is equal to minus 1, then return, I mean break. Yeah. Okay, so basically what happens is, in this case, okay, let's see 1. Okay, so it comes here, it's all set and all. Now you see nums of k. So 0 and nums of 0, that's 1. 1 equal to 1, yes. So k minus minus. So k is already 0. So it goes minus 1. Okay, and then it comes again. Then what happens? Nums of minus 1 is checked. Okay, here nums of minus 1 is being checked. What is being checked? Nums of minus 1. As you know, nums of minus 1 cannot exist. This doesn't exist, and therefore we get segmentation fault and memory fault, because you can't access an element which does not exist. So what we do is simply, after this statement, if k becomes -1, we just break out of it and khalas. That's should be our answer. Yeah, so there you go, it has been submitted. So like, share and subscribe.